I'll use lots of colors. So I guess there's two ways of looking at building it out, right? We started talking about VNets and what's VNet, so you can look at the tree down that way, or you can look back up the other direction. But we're going to, following Krishan's lead, he's learned it recently, so you tell me if this is the best way to learn this. Is it? We'll start with what we call an eye edge. So an eye edge, we'll also refer to this as endpoint. And a lot of this, and my handwriting is just atrocious, so you'll have to bear with me.
Here, I'm just holding it.
So an eye edge is also what I refer to as an endpoint. It's the equivalent of a session agent inside of some other SBCs. So think of the eye edge as a session agent. You can apply just all the maximum amount of policy stuff you want to an endpoint.
Okay.
There's 350 different flag options. You can also apply header policies and header rules to do anything that we don't have something that has a flag to already accomplish what you need to get done. Okay. Eye edges are required. One of the requirements, there's a minimum amount of stuff that's required inside of it. The rest of all those endpoints get certain default settings. The requirements for an eye edge is an IP address, roughly. There's some outlier cases we can talk about later. Obviously, we have support for if it's just an FQDN and we're going to go resolve it, and it can be multiple IPs, but it has to have some way of being able to contact it. You have to have a realm assigned to it. So it has to know, hey, if I'm going to go to this endpoint, if I'm routing to it, where am I going to source my layer 3 packet from? And that would be the realm information. You have to have what we call a type. So is this SIP, dyslexic, sorry, SIP, or H323? You know, what protocol is it? What type of is the machine? And essentially that's the minimum that you have to have for an endpoint. Otherwise you can default and take everything else. Now, if I don't have information on how to steer something to this endpoint, just by creating it, all I've done is allowed it to send me traffic, right? Because if I want to send traffic to this endpoint, I need some way to steer it. So let's just write steer here. So there are multiple ways of steering traffic to an endpoint. You can use calling plans. Not really used much in your solution. Mainly everything that we use to steer stuff here is with trunk groups. Right. Now under the trunk group configuration, you can apply OTGs and DTGs. OTGs being origination trunk groups, that's going to be trunk group and trunk context information that goes generally in the contact field, and destination trunk groups, which are basically TGRPs and trunk contexts that can go into the request URI. You can also apply specific trunk group values and trunk context without using it to steer stuff. So what we do is we have flags that we're using to steer things through the system, but keep the trunk group values that you guys have given us to be preserved in the signaling itself. So in the configuration, I'll show you, what those values are and kind of how we use them. So let's go there. So here we're going to start creating the endpoints. The first endpoint we're going to create is the SRP endpoint. This is the SRP endpoint for outbound calls. So I'm going to drive you crazy.
Okay, no, that's cool. No, you're good. That's why it's on the swivel.
So we're going to do the outbound call flows in blue and the inbound call flows in green. They actually use different endpoints for the most part, but they could use, in theory, the same ones.
I think that blue actually isn't,
Blue?
No, it's just not a good marker. It wasn't dark.
She wants to use the pink that's up.
You want me
I'll use
to grab
the pink and the
some
green.
darker ones? Let me grab you just a dark one.
Whoa,
Right
they're
quick.
dark, dude.
I mean, not really showing up on the camera that well, but that's all right. That's okay.
That's what I
It's
said.
okay.
Let's do...
You can use another color. I mean, they said that blue was the one that was in here and it just didn't come up.
It just didn't come out right?
Yeah.
Oh, this is fun. All right, so the first endpoint we're going to create is called SRP.1, based on this. If we're going to look into the two networks, or the networks that the SBC is bridging in, we have a core network and a peer network.
So I have a question, I'm sorry.
Sure.
So where you're adding this SRP, in theory, would this be like for us, like when we would do the FQDN, or is that just like an arbitrary name, SRP1?
I'm using SRP1 to represent one of the SRPs that will be sending calls for outbound call flows inside of a certain calling plan. I think once I draw the whole thing out, I'll be able to explain. I know what your question is. I don't want to get too deep
That's
into
fine.
it. I'll try to get there quickly though.
No, that's fine.
So outbound call flow is what we're looking at. In the core side, you guys have individual SRPs, right? You can have 3, you can have 10, you can have 100, however many you want. Each one of them have a unique IP address. Each one of them are going to be signaling to the core realm on the SBC, right? So here we're going to create SRP1. When it's time to create SRP2, we're going to call it SRP.2. You can call them anything you want, right? I'm just getting them rough names right now that's currently in the DVD. So SRP1, we're going to create it. We're going to give it a static IP address. So we're creating it for SRP1. We're going to give it an IP address. And it's going to be equal to 1.1.1.1, right? So that's how you use the static command for when you define the IP address to the CLI. We're going to put it on realm core Comcast. So core-Comcast. So now, just based off this information alone, when the SBC sees a packet come in, and it comes in from 1.1.1.1, and the packet's coming to whatever the IP address of the core Comcast realm is, now I'm going to start being able to locate what endpoint this is. So just from that layer 3 communication alone, I can go, hey, I'm going to start applying policy potentially to this endpoint as if it is this person. There's more things I can do to identify it and ensure that it's the right ingress endpoint later. But that's the number one thing that's going to start keying it off. It's a type SIP proxy, so now I know, hey, when I signal to it, it's SIP. When it comes to me, it better be in SIP. I'm putting it in an IGRP called Core Comcast. The IGRP is the closest equivalency that we have to a realm inside of Acme. The reason that we're putting it in this IGRP called Core Comcast is for one main reason. It is to meet a CDR requirement.
Okay.
Because you guys, inside your CDRs, you group lots of endpoints together.
Okay.
Say like one was called core or peer quest or peer customer name, right? And then that gets written in the CDR, and Paul uses that for certain things. So you're going to locate all your endpoints that are quest endpoints, and they'll be in an IGRP called peer quest or whatever that specific name is. What that also allows you to do is when you start running calls through that box, you can also go to the SBC and take a look at your IGRP information. And what let me explain what an IGRP is.
Thanks.
IGRP is what an iEdge group. And all an iEdge group is a collection of endpoints that I want to apply a specific policy to that spreads across multiple endpoints. So if I look here, I can see that the core Comcast endpoint, the calls, we've got calls that are going on right now. I can see how much bandwidth is coming in this I group, and you can also see that same type of information. Bandwidth in, why is that set to that? That should be zeroed out. Or, that's strange, I need to look into that to see what's going on. I would have expected it to be 0. No calls. All right, well, anyway. But you can actually cut up inside of the I groups. You can see where your call flows are. How much bandwidth is Sprint taking from me? How much bandwidth is this customer taking from me? How much bandwidth is going to my core?
Just, I'm sorry, side note, Paul was able to get the CDRs,
Okay.
so, from Genband, so that's good.
Nothing from Fritz.
Okay, so Alan, what was the command to actually show that again?
Oh, yeah. It's CLI IGRP list.
Okay.
So, as you notice, all of our commands that I've got monitored here, everything starts with CLI. And then the next object is going to be what the object you're looking at.
Okay.
Whether it's a realm, a VNet, an IGRP, or an iEdge for endpoints. And then you can do adds, you can do edits, and then list will always show you what's inside of that object. So if I were to do a CLI VNet list, it'll show me my VNets, right, and how they're configured.
Okay.
You should
And of course, you can list
You should
the,
implement the tab functionality also.
I agree, I would love it. Unfortunately, Linux has already taken the tab, so it's going to try to actually just fill it in with a file name, right?
Oh, good.
So, because if I do CLI and then tab, it's going to just show me all my files. But there is actually, there's talk right now, we're looking at remapping the whole CLI so that it's more object container based. That way people can have their own option of whatever they like.
okay, you can also list the items by name as well, right?
That's
The
right. You
entities
can
by
do a
name.
lookup, an LKUP.
Okay.
So if you knew what you were looking for, like if you do an endpoint and you want to find something just based on its IP address, I could type in just the IP address of whatever it is, like 10. What's the IP of something? 192. 82.
That's 253 it is.
1053, 135.
And so now I've located an endpoint based on just its IP address.
Cool.
Only problem is if you have like 100 of them, you won't be able to remember the names and IPs, right?
Sure. So then
Okay.
you can dump everything out. So as with an endpoint list, you see tons of information.
Okay.
With like realms and endpoints, because there's so many options, there's also a brief command.
Okay, cool.
It doesn't show everything.
That was my next question.
So if I were to do CLI IH, now I can kind of see multiple endpoints with just the small amount of data that's there.
Okay.
And then you can always put this out to a file and then search through it in VI. So just to be honest, I mean, the more Linux experience you have, the easier the box will be for you. It will force you to learn
My
Linux.
head's hurting. As you type. My
And
head's
so the VI list, and then you can go in here, and then you can search, with your normal VI commands for whatever I'm looking for. Object, and try to find what you want. The GUI is a lot nicer, and it's fully functional, so you can find the stuff through the GUI just as easily.
Thank
Let's go to the license room, we go bring yours in.
Yeah, you want to? You mind? Then we can also show them some of that too. All right. So finishing configuring endpoints here. We got to iGroup, and then I got way off on a tangent. Now we're going to set two other things here. We're going to set egress DTMF to N-band and set DTMF to default. What that's saying is if negotiated, if you need to do DTMF translations, you'll have access to a DSP to do DTMF translations. Every one of your endpoints, other than your redirect server, should have that enabled. What we don't want to do is ever set up transcoding information to the redirect server, because what we're going to do is we're going to go, oh, I'm sending a call out, send stuff over to the DSPs and get ready to do transcoding. Oh, I got a 302. Now tear that down and set up again, because you're going to be going somewhere else. So by default, we're just going to never do anything with transcoding directly related to the redirect server, because it's going to just save us CPU cycles. So those you'll see on every single endpoint. You're going to see a codec profile that's listed there, the CDC PRFL. That's going to map back to the codec profiles that we created earlier. So now this endpoint, if I need to remove anything or add anything to it, it will be applied to the codec profile. The transcode option 2 is set. So here are your transcoding options. 0 equals not defined. And I'll go over what that is in a bit. 1 is disable. 2 equals static. 3 equals proactive. And 4 equals reactive. Inside the help, inside the CLI help, and you'll also see this listed again. It's also an operations guide. From the GUI, it doesn't say this, it says this. So it's easier to know what you're setting anyway. But you'll see here that we're setting this endpoint, the SRP, to have the capability to do static transcoding. We've got the IGRP in there twice. I mean, it doesn't hurt anything.
Yeah.
Then we're going to put it in what we call a partition ID of 1 and in a zone of 1. The only relevance about that is, so what a zone in a partition is a way of splitting the SBC into virtual SBCs. If I'm to take an SBC out here that has a bunch of endpoints and calling routes and everything else, I can put them in zone 1. I could create another zone called zone 2 and put a whole bunch of other calling routes and endpoints. If a call comes in to zone 1, and zone 1 doesn't have a way to route that call, we won't route it. Even if zone 2 did have a way to route that call. These two zones are basically separate SBCs that can't talk to each other, so it's just partitioning. We're setting it up because the RSM likes to have zones and partitions. Everything goes into a zone and a partition, and by default it goes into the zone 1 partition 1. So this has you set to be able to modify stuff from the RSM and modify stuff from the CLI. Also in the future, if you wanted to separate your call flows, if you wanted to say, hey, I've got some rules that I need to apply for inbound calls, say, hey, I want to have a cleanup rule so that if I never find a way to terminate it, always send it back to this direction. If you were to, you know what I mean? Like, there's all kinds of ways you can do that. You can create, you know, a calling route that matches any number, and then it gets put on an endpoint. But you wouldn't want that to match going for the outbound call flow. And you could put them in separate zones, that way that policy wouldn't apply to everything. Or if you wanted to start mixing and matching, let's say you wanted to put a wholesale SBC together with a peering SBC. You'd put all the peering endpoints and peering rules in one zone potentially and something, and all the other endpoints in another zone. That way that things just don't conflict and kind of run into each other. By default, our current implementation model, everybody's going to be in the same zone and partition, which is 1, and that's all this is doing. Putting those in.
The realm and VNet will be common to all partitions.
Yes, that's correct. So now we're adding this endpoint called Quest 1. Quest 1 is part of the outbound call flow, or part of that model. And it goes on the peering realm. So we're going to add Quest. What? What did I do?
No, it's not. It's
Because I keep getting her every time I... Wow.
So now we're going to add Quest 1 for the outbound model. Obviously, this one's going to be a bunch of endpoints. You guys are going to add lots of peering partners and whoever else that goes there. We're going to put it in the realm of peer Comcast. So it goes into peer Comcast, which is this realm. And it's a SIP proxy. We're going to give it an IP address. Let's say we're going to give it 2.2.2.2. Header policy profile. So just like with calling routes, you take a whole bunch of calling planes, you take a bunch of calling routes, you put them into a calling plan, which is just a folder, and then apply that folder onto the endpoint. Header policy profile is the same way. A header policy profile is just a collection of a bunch of header rules. The header rules are actually the meat that actually makes the changes, right? That's, hey, search for this, change this to that, insert this, do, you know, whatever you want to, whatever kind of rules that you're creating. So we've created a header policy profile called Outbound Comcast, which I'll show you what it is up above, that we're applying to this endpoint. There's another flag here that we're using called use 4904 trunk group enable. That just makes us, it's a backwards compatible type flag. So initially, when we actually did trunk groups, I don't even know if that RFC had been written. It was just a draft, and we did certain things the way we wanted to do it. Once the RFC came out, we needed to match the RFC, but we needed to stay backwards compatible for anyone who deployed in that manner already. So by default, use 4904 TG is set to disable. So if you want to use the strict or the stronger implementation of 4904, you have to enable it on a per endpoint basis. So we're going to set that to enable. We're going to set a destination trunk group of LD out and a destination trunk group context of sip.nw.quest. So what's going to happen is now I'm saying that this guy can be LD out and the TGC of sip.quest, or I'm not sure exactly what it was. So what happens now is when this SRP1 sends a call that he wants to go to Quest, he's including in the trunk group and trunk context of the request URI a TGRP equals LD out and a trunk group context equal to sub.quest. The SBC receives it and goes, okay, I have a trunk group in the signaling. Do I have any endpoints that match this combination of trunk group and trunk context? And it ends up finding this endpoint. It could also find tons of other endpoints if it wanted to as well, but it definitely will find this endpoint. And now it knows I need to steer this call to that endpoint. Right? So that trunk group and trunk context are there for the steering purposes of whatever is going to be in the signaling coming from the SRP.
This is like a tag.
Yeah. It's always a combination of both sides.
Yes.
So if you have a LD out and another one called SIP.cabulation, that will be a different.
That's it. So it might as well be called XYZ and ABC, right? Like it needs to match both for it to route correctly. And that's the 4904 implementation. If you were to set that to disable, then it would only match just the trunk group. It would only have to match just the trunk group. Now, what we're doing, we're saying set des.tg to disable. That's because we don't want the trunk group and the trunk context going to Quest that we use to route internally. So we've set that to disable. Then we have IGRP equal to peer quest. We talked about IGRPs already. We're setting our DTMF translations to be enabled. We're using a codec profile of 2833. So all we're going to do, that profile was just to insert RTP telephone event 101. We're setting the transcoding type to 2 for static transcoding. Remove TG, that's to remove any OTGs that would be in the contact field. And then PID would be, we talked about that, this is for the partition ID of 1, and we're putting Quest in zone 1. So that is all you do for your outbound call flows. Everything's just steered with trunk group and trunk context. You create the ingress endpoint, the egress endpoints, and then based on the signaling that comes from the SRP, we locate the termination endpoint, and we route it.
You need to add those under those configurations on each of them.
Yes, so what I've done inside the DDD to see that has all those new features are highlighted here, right? So here's a combination of stuff that you guys said, hey, we need to be able to do these things. These are the flag names associated with it. And also, Kristen, your destination suffix, it's in, so now you don't have to create 1,000 calling routes to block 5551212. So these are all the ones that we recently added that we talked about. So you can mix and match. Obviously, I didn't put it on Quest because sometimes you may use it, sometimes you may not. Who knows what the carrier is going to want to need. So it's kind of hard to match, but the information is in there. So is everybody good on the outbound call flow? How it works, why it works? Is that similar to how you do it on the Acme?
Yeah, I mean, this is, I would say a little
Can you
more,
mention about the
but it
priority
is,
stuff?
it's similar to, I mean, the logic
Yeah.
is the same.
Okay.
Can you mention about that priority stuff on setting up a different, let's say the Quest has 2 different SPCs on their side.
Sure.
So you have two IPs and 2 IHs. So how you can, how to do a round robin or a hunt between those 2 SPCs if required.
This is how I would do it. Normally whenever I'm adding something, I end up creating a notepad, and I'll take my commands and kind of put them in, figure out exactly what I want to paste in, and get the logic that I want correctly before moving on and doing it. So we're going to put this in, and this one's going to be, another Quest entity. So since now I've added, let's just do this. Let me. So here I would have 2 endpoints that I've just created for Quest 1 and Quest 2. The only thing I really need to add in here would be the IPs of where they're going, right? So we're going to say this one is for Quest 1. Here's the IP address for Quest 2. If I want to make any other changes, whenever the SRP sent me a destination trunk group of LD out in a destination trunk context of SIP and WQuest, I'm going to locate 2 endpoints now that can potentially route this. By default, everyone's priority is 0, which is the lowest priority there is. So when I have more than one way of routing something using the exact same mechanism, like a trunk group, I'm going to just round robin it. So if I wanted to pin Quest 1 as the primary and only use Quest 2 for a failover event, I would just add a priority command. And priorities can go up to like 600,000 something. I mean, it's huge. So I'm going to just give myself room for something else. So now he's at 0 because by default it's set to 0. He's set at 100. The higher level wins. So now all calls will go to this guy first. And if he fails the call or sends a reject code that's inside of the code map file, then I will route advance to quest number 2. And so I could load up as many different endpoints with Quest using these exact same destination trunk groups and destination trunk context, and either round robin across them, or I can also use them as failovers. You guys want to go into percentage based? Let's say I wanted to route every 2 to this one and 1 to this one. 2, 1, 2, 1, 2, 1.
I don't think, I mean, right now I don't use it.
That's not a requirement? Okay. We'll talk about that.
You can also say about the U-port numbers, like when you create CMIP and ALM, you need to have.
Okay. Just in case it wasn't complicated enough yet, I'm going to make it a little more complicated. Whenever this IP, if this IP and this realm ever match again, you can't create a new endpoint with this IP in that realm. It has to be a new U-port of this same endpoint. And all a U-port is what this 0 number is. That represents the U-port. So let's say that Quest, now we're sending stuff to Quest with SIP. Let's say Quest also, for example, wanted to do H323, right? I can't go in and add H323 to this endpoint too, because then when I try to go hit this endpoint, I'm going to say, well, he's already a SIP endpoint. He's a SIP proxy. So, well, sometimes there's certain calls I want to route to Quest that do SIP, and certain calls I want to route to Quest that do H323. So now I'm going to create another endpoint, and it's going to be, or another U-port, add Quest, and this time it's going to be U-port 1. So now I've incremented the U-port by 1. That gives me all the options in the set world of a normal new endpoint, except it's going to just inherit this IP address and this realm. Okay. So now I could do IH edit Quest 1.1, and I could say type H323. I could also give it a new routing mechanism. Right. So now when the SRP ends up sending me a DTG of Quest-H323, I'll locate this endpoint and I'll go to Quest using H323 instead. So if you ever get an error when you're trying to add an endpoint that says duplicate entry, chances are you probably already have an endpoint with, is that what it says, same realm and IP? And so then you just find that endpoint and then you can add a new U-port of that endpoint.
So this one, the first one will, it will default route to 1.1.1 port 5060, right?
Yes. If you want to go to a different port, that's when you have to update the contact. Yeah.
I mean, that's why, that's when we use it for, in our JS scenario, which you always are, Ray had sent all those things, right?
That's right.
For different ports.
If you want to locate an endpoint by an FQDN, what you would end up doing, and actually we'll get to that, we're going to talk about the inbound call flow next, which we actually do all this, so I can show it. I just want to make sure everybody feels okay about the outbound call flow, what the configuration is, why it does what it does.
I think we can talk about the code mapping and route advancing at this point.
You want to do that before we go to the inbound call flow? Or you want to do
Yeah,
the-
now, I mean, with these two, Quest 1 and Quest 2, right?
Yeah.
We can have a code mapping and
Okay.
router runs.
Okay. All right, so before we go to the inbound call flow, let's talk about code maps real quick. Everything go good with the, okay. Did you add the devices already?
Yeah.
Okay.
That's right.
Okay, well then actually then before we go there real quick.
No.
No GUI?
Angel will be happy.
I know, I don't wanna, you gotta keep Angel happy.
Do you get that on tape?
So to go to the GUI, 10.255.
173.
173.100. You'll go to the IP address of the RSM. And it's going to give you a login page.
Is it the same root?
No, it's going to be, the password is RSM at 123 exclamation mark, exclamation mark.
Oh, I'm sorry, I changed it. I haven't changed it.
Oh, no, that's
I
right.
emailed you. It's RSM 123 exclamation.
Just no at?
No, I said.
Gotcha.
The,
You can, everyone gets their own username and they can choose their own password. RSM just, as part of the process, it's like, oh, I'm going to require you to change the password now, and now you've changed it. And so that's why it's different than the SBCs right now. So
And no radius?
no, there's radius support.
There radius. All right. That's
Yeah.
what we would need to set up.
Okay. Both on the SBCs and the RSM, there's authentication for the radius. So the RSM console is the GUI provisioning tool. Oh, you know what?
someone's phone is.
Okay, and just curious, the acronym
All right, so
RSM
no one
itself.
log in for just 1 second. Give me 1 second, okay?
Okay.
That's why I got kicked out.
Yes, only
First
one
time.
person. The default setting is that one user can only be logged in at one time. So I'm going to change that, but I can't have anyone knock me out until I do it. Allow multiple sessions. Allow 10. That should be enough.
I did apply.
Oh, you already done it?
I put 5, but I guess.
No, yeah, I haven't taken it. I don't think it gets submitted.
Oh,
All right, so now everybody else can log into it.
So the user ID was RSM.
Root.
Oh. And password.
RSM 123 exclamation mark, exclamation mark.
And while that's loading, the acronym RSM itself.
Real-time session manager.
Okay, cool. Thanks.
Also, just like iEdge, we also refer to as endpoints most of the time.
Mhm.
RSM, you may hear be called IVMS, potentially NARS. Any
Okay.
of those things kind of mean the same thing. As products grow, as our product has grown, like our first generation network media card was called the Hot Knife, or HK.
Okay.
And then we called them NP, NP2s, NP2Gs, NP3s, and NP4. So we have all these, but yet still sometimes you'll end up hearing someone refer to or even see in the lines error in HK, which means error in the media card. So I'm just trying to throw out all the acronyms so that if you see something, it might go, oh, that actually means this.
Okay.
So,
Cool.
virus scanning is going on.
I recommend Safari.
What?
I recommend Firefox. That's what I use Safari, and it works way better
Way better.
for me in Firefox than
I should.
like it just came up as soon as I
It's already up here?
yeah.
Wow.
Yeah, and just from using Safari back in the day, I always use Firefox. I would have problems with it with IE.
Does this make use of Java a lot?
What?
Does this make use of Java?
The GUI does, yes.
So that's why, because IE is not good with Java. It's very, very slow.
Very good. Okay. I have Chrome. I use Chrome a lot. But
Clearly, you're a CLI type of guy, Alan.
I I avoid GUIs like the plague.
You say you avoid GUIs like the plague.
Well, I mean, honestly, it's just kind of slow. Like, if you want to make mass change, you open the endpoint, close all the information for the endpoint, make the change, close it, wait for it to push down. You know, I just feel like I can move faster in a CLI. In a CLI that I know, if it's one that I don't know, then I don't do as well.
No.
And for documenting purposes, I just find it's easier to document with CLI than if I'm telling somebody, hey, go enable this flag. It's easier to do that than.
I would agree with that piece
Yeah.
of it. But I think, I don't know, I'm CLI. I mean, Acme's easy.
Because you know it.
Yeah.
Once you know this, it'll be easy too.
It will. But I'm like a 5e I'm way old, like 5e. And 5e was loose. I mean, yeah, it was GUI. You know, you had to get in trunk line workstation every now and then, but that was GUI, so. I think most of you weren't even around when 5es were still being used.
Okay. Nah.
No,
The
Bryce,
DMS?
we're the same age. Did
Craig.
you say DMS?
Yeah.
Lucent? Lucent.
Yeah, no.
Oh, I know. DMS used to make me sick to my stomach as well. Because we didn't have a GUI for DMS, so after being in Lucent so long, after 5e, when I went to RCN and they had a DMS, I'm like, what the hell is this?
DMS is fully CLI, right?
Yeah.
It's different.
Yeah.
I think so. This guy can tell you all about a DMS, probably, I would guess.
It's brown.
Is what?
It's brown.
It's what?
Sometimes gray. It's
Oh.
brown and sometimes gray. What more do you need to know? Do you guys not have the one downstairs anymore?
I think it's still, did they decommission it? I think they may have decommissioned it.
Very well. You got it on the upgrade on the core.
Yes, sir.
It was one of the XA cores, the last I seen it.
Very
Yeah, I
nice.
wouldn't say, because in my mind, I think they decommissioned it. In my mind. I know everything that we used to have.
They fixed it, all you gotta do is select the
Going
first one.
through the DMS and then
Choose them all now.
RCA.10.
That's about
I
time.
think
Okay.
that's whatever we just did it.
I wondered what the RSM engineers were doing.
Yeah, on this tower you come back here, to the right is production. So that's
But
where
what do you use it for?
it was live traffic off of it.
Yeah.
And that was during the,
Tab.
Who's that?
yeah.
Talking?
Okay,
Mhm.
that's 250, DMS 250 or 500? 250,
I know Bob used to mention it. Did you ever work with Bob? Yeah, that's his stuff.
So this is the GUI for the SPC. We refer to it as RSM console. You'll see all the endpoints that we've created. So here's SRP 22. I named it 22 because it ended in the 22 address and the document called .1. You guys, I know you're going to come up with your own naming standards and everything else, so everything I'm sure will change. But here, if you wanted to load it, you can click on the U port. So this is all the U ports underneath SRP 22. And under here, if you needed to quickly browse all the settings, you can see everything, just by scanning over. If you double click on it, it will give you the option to be able to change some of these settings. You'll have multiple tabs of pages, but it takes a few minutes to kind of load the thing. I think part of my problem is too, I think we're rate limited, and I don't know if on the wireless it may not be, because you guys seem to be moving a lot faster than mine is. But I know like whenever I transfer files, I can only get like 200K a second or something between the switch that I'm on and the SBC. Of course, that should still be plenty to download. Shouldn't have to download any much more than that anyway. But there we go. No, it's fine. All right. So here's the configuration page, and you'll see the IP address for the endpoint. These are all the same options that exist inside the CLI. If there's ones you want to specifically go over, let me know. I'll highlight a couple just as we kind of go through the list. So extension. Whenever we route, I'm going to go off on a tangent again. Whenever we route, let's say a request comes into the SBC, And now the SBC has to figure out what it's going to do. There's so many different ways of routing inside the SBC. There's basically an order of operations, what trumps what. The number one thing that we route off of would be extension. So it's rarely ever used. Okay. Number two would be the URI, so the domain inside the URI. If the request comes into the SBC and the FQDN in the request URI or the IP address is not that of the SBC, we're going to assume that this is basically a proxy request that someone's sending to us and they want us to forward to that domain. Number three would be trunk groups. Number four would be calling plans and calling routes. So those are the four main things that we'll route by. So let's say on this endpoint I applied a calling plan, a trunk group, and I stuck extension of 1234. If a request came into the SBC to go to phone number 1234, it's not going to. We're going to trump everything because this endpoint has the extension 1234. It's the topmost piece for routing. So you rarely ever use it except maybe in a case of, hey, 1-800-COMCAST always needs to go to this endpoint or something like that, right? If there's something, it's a way to kind of trump all your other routing if you need to for specific things.
Can we do a wildcard on this?
No. Feature request. A wildcard would be if we use calling plane, right? We'd use calling planes, you use wildcards and things like that. So that's where we would use the calling plane. Calling plane is just that. When you create your calling plans, if you want to apply it to the endpoint, you can see it shown here. Realm, we kind of discussed that. That's one of the requirements for an endpoint, that it has to belong to a realm. You'll see it belongs to this IH list. Here you'll see your transcoding options. Instead of them being listed as 0, 1, 2, 3, 4, they're actually listed as to what they are. Codec profile. That's all for this tab. So then as you move across, you'll see you get more and more options. So subnet IP, what this allows you to do is, let's say that you had a network of a whole bunch of SIP proxies, and they were only used to process calls coming inbound. You could put in here a subnet IP and a subnet mask, and that way anything coming from that network would be treated as this endpoint.
Cool.
That way you don't have to go create 255 or however many that may exist in the network. They're all going to be treated the same. Outgoing prefix, anything that goes to this endpoint, we will append what is ever in this field to the user part of the request URI. So if you knew everything in your network was 10-digit and this one endpoint needed E164 and you wanted to put +1 in front of all of them, you could. Or it's also used in some peering agreements. Some people end up using it to say, hey, anytime you see a call from me, it will always be prepended with 55 ##, or something like that, like steering digits kind of thing. IPsec. If you ever need to do IPsec, we can do IPsec on the from the signaling point of view on the SBC. Actually, I should show you this. So that the DTMF information that we talked about is listed right here.
Okay.
Inside the GUI. User info. All this information here doesn't affect any call flows, but for each endpoint, if you wanted to put a contact name and phone number that would go along with an endpoint, if you wanted to speak to someone, you can store information about an endpoint here. So it's a little more than just a comment field. And actually what we do is, I think it's last name. We have this field as a special field that you can use anytime we write something into a CVR. We'll also record the last name, whatever's in the last name. So if you ever need a trick or something and you're saying, hey, whenever it goes to this endpoint, we need to store something in a CVR from Paul down the road, that exists there. So it's something that you can use. Protocol, here's where you can choose between SIP and H323. Obviously, configuring under SIP, there's going to be lots of additional information. Here's where you put contact information that we've used before for some of the other endpoints. You can put, if you were to put 1234 at 1.1.1.1, like this example right here, anytime we go to this endpoint, we're going to overwrite what the phone number is with 1234. So normally you'd want to leave that blank unless you knew everything going to that endpoint needs to go to that specific phone number. So you could put in an IP address and then also change the port number if you wanted it to go to something other than 5060. Just because this field is blank doesn't mean you need to fill it in. Otherwise, we'll just inherit whatever was coming from the ingress side.
Okay. So right now you're gonna, I would imagine, in Olador, you're gonna go over the step-by-step process of setting this up, the box up from the GUI.
Sure.
Right? Okay, cool. That's what I prefer.
Yeah, well, I mean, we can create. Why don't we create some endpoints, or why don't we do something? I mean, what if we remove like the SIP stuff and then add it back in and tie it all together and make it work?
Cool.
I mean, does that seem like a good
That
exercise?
works.
Okay. So, first step before you do anything crazy like this is you back the database. So here's you'll see how I'm backing the database up. CLI DB export, and then you just give it a name. So I'm going to just call this DB 319 XML. So now the whole DB is now in this file. Right, so I don't have to worry about it no matter what we do. We'll come right back here. I can load it in.
Is there a limitation on how many backups you can have?
No, it's all Linux based, so you have tons of hard drive space. The files generally aren't that big, especially with you guys' configuration. There's not that much in it. So
Could you do a show or like some sort of list to see all the existing backups?
yes, so what you would do is you have to kind of come up with a process. What I would recommend doing is something like make a directory called backups, and then have a cron job, which is would run every day at 3 in the morning. That just exports your database and puts the day's date or whatever else, and then and always puts it in the backups directory. So then you can change into backups, right? And you'd be able to see. So if I do CLI so they're my database files, right?
And if we wanted to restore a previous backup?
You do CLI DB add and the name of the database.
Okay.
Now to add a database back in, I would recommend stopping the system and then dumping it back in. If there were major changes, right? If you're gonna have major plumbing changes and stuff like that, and you got calls going on, because if we have calls going on between a realm that doesn't exist, and all of a sudden we rip that realm out, and all this stuff goes flying around inside the database, you could get some unexpected results.
And we would normally do it, just, I mean, like today, where we use one SBC for both peering and wholesale, and there are different configs.
Sure.
We just normally try to, and Sean does stuff, and then I break what Sean does, and that type of stuff. So we try to have, like, if he's doing a peer specific, he might have a config for like Bright House. So just for him to restore. So in theory, there shouldn't be anything crazy going on when he does.
It doesn't restore. You should be fine.
Okay.
Like Alan, any changes getting made in the RSL, they don't automatically go to the SBCs.
Any change that's made in the RSM immediately goes to the SBC. So if we make a change, if I do this, and I go, hey, let's add a new endpoint, we're going to add a new SIP proxy. We're going to call it one. I'll just give the minimum information that I have to give here, and then we save it. Now, as soon as I come over here, that is immediately there. So any change that's made in the GUI immediately pushes down to the SBC.
Okay.
If I make a change on the SBC, it does not immediately get reflected in the GUI. The GUI goes down and audits the SBC every once in a while and goes, oh, I found a new endpoint someone's created. Let me sync that back
So
up.
that's a defined interval.
Yes.
So for the most part, you can't provision and schedule a change to like take place after midnight, or
No, you can.
You can.
You can also
Okay.
manually sync on the RSM too, right? So if, let's say you and Sean are working on something and Sean makes some changes and you go, wait a minute, I know that this may not be accurate reflecting what was there before. You can go to the synchronization tab and do a manual sync. So you can come in here and say, okay, all let's do MSX to RSM. So now I'm going to push all that information that's in the MSX up into the RSM database. I can also do RSM back to MSX and overwrite everything that he just did all the stuff he did in the CLI and push it back to the way I wanted it. So,
On purpose.
Is there
That's
any
cool.
difference on like versions, like you go from one major release to another release, so the backup you created on the old release won't work in the new release?
yes.
So you said, like, with a major release where your backup isn't compatible with the new release. And you're saying yes?
Yes. I'm not saying it won't work. I'm saying that is, if you were to go from 5.2 and you had an old database, and then we upgraded you to 8.1, and then all of a sudden you go, oh, you know what, this was in a database from 6 months ago, let me go grab that 5.2 database. When you go and import that database from 5.2, there's going to be all kinds of new features that 5.2 didn't have any record of, and there could even be some kind of other changes that may happen. So when we upgrade, we know what to do. When we have an old database, we may not know exactly what to do. If you run into a situation where you want something done like that, let me know, let Alan know. What we can do is we can take care of the conversion in our lab. It's not as straightforward as, hey, let me give you a tool and it'll just take care of it for you. We have to analyze what the changes are, see what it is, but we will give you an XML file back that is now compatible with the version that you're on. And for minor releases, it's not a worry, but major releases, okay. So, what did the SIP boxes, what are we calling the SIP machines now? Is that what these wholesale SIP, UAC,
Yeah.
Core and Peer? Okay. So if I just delete all three of these, would you have a problem with that?
No, I have the configuration, I can do it again.
Okay. So what we're going to do is we're going to delete these endpoints, and we're going to re-add some SIP endpoints so that we can run traffic through them. And I may be asking you questions now that I've deleted them. Well, I've got the backup in the XML, so I can look at what the IPs or whatever it is. Does somebody else want to drive, and I will tell them what to do and how to create it?
We'll give Angel the honors. Go ahead.
Angel, you
Make
want
it
to use your
happen.
laptop or do you want to use mine? Because I'm going to put you on screen.
Angel, I'm preoccupied, recording the session here.
Oh, is that right?
Yeah.
The way I move around, it's
Yo, Steve and John.
HB6 key.
By 5 o'clock. It's crazy. It's just... This is like the 5th email. It's too much. Okay.
He talked to Alex. Or me.
For proof of concept isn't even done, right?
Hmm?
For proof of concept isn't